countering malicious trust developers, and countering malicious untrusted developers. And there's all those ways to do that. A little bit for time here. All right, I'm going to switch gears very briefly for a topic that I think is interesting, but I do want to make clear it's switching gears. Most of my talk here has been for really all open source software, but more focusing on software where you in principle know what you're trying to accomplish, you know in principle how to accomplish it. There are details, of course, to work out in order to do it well. But what about research? Can open source software aid in research? And I believe the answer for that is yes as well. So you're using open source software. In this case, it's still open source software. There's still open source software licenses, but you're using it in a somewhat different way. And so I'd like to talk about a problem that's in the security world, which is we would like to have something called high assurance, where currently today most software, if you want it to be secure, what we do is we try to reduce risk. And that's fine, and that's appropriate, and that's what we need to do right now, is find ways to reduce risk. Find ways to do things like, for example, make sure that only certain pieces of the software need to be especially highly reliable instead of the whole thing. Use reviews, use tools to examine the software, do lots of tests, and identify common mistakes and look for them in particular. And as I said, these are all fine and appropriate things to do. But what we'd like to do in the future is have software where I can prove to you that it is absolutely impossible for something to happen, or is absolutely required that something will always happen. These are much stronger claims that are much more difficult to do with today's software development processes. It turns out there are ways to do this, and they involve something called formal methods. Formal methods are basically mathematically based approaches to developing software. They have a lot of promise. The problem is that they've had promise for decades, and they're not widely used even now. The progress has been slow, unfortunately, in the formal methods area. And there are a variety of reasons for that. But I believe one of the important reasons is that what we've ended up through a series of unfortunate events is basically stovepiped and stalled research. In many cases, formal methods research often do not share their implementations, code at all. They often forbid industry use, which of course is exactly backwards from what you want. And there's very few public examples with enough details to actually use that. And I think you can imagine in the situation where everyone's trying to make improvements, but everybody's trying to keep secret every detail, this is not a recipe for progress. This was the state of mathematics, at least in the Western countries, the 1500s, where every mathematician would develop an approach and then hide it from everyone else. There wasn't a lot of progress in mathematics that way. This is a quote from a peer-reviewed paper, actually. Basically, from publications alone, without access to the source code, they couldn't make progress in what they were doing. When another research group released their source code, all of a sudden, the problems they were having became clear and immediately resolved. So, what can we do about this? Well, that quote right there suggests what we can do about this. We could use open source software approaches to create what I would call an ecosystem, where different people with different roles can work together in an environment that legally permits this instead of forbids it. And what I'm encouraging for this particular area is the development of what I call open proofs. Open proofs are where you have source code proofs and the required tools to manage and maintain those are all open source software. And that means if you have an open proof, that means that anyone can examine, critique, improve, collaborate with others. Same argument that for open source software in a more traditional non-research area, but applied to the research areas instead. And this enables collaboration, learning, and so on. If you're interested in this, you can see that little website right there. So, bottom line, from a security vantage point, and I do want to emphasize this, I'm focusing here on security. Obviously, other speakers will talk about other advantages and so on about FLOSS. Neither FLOSS nor proprietary software is automatically better. Just because a particular program has a FLOSS license doesn't automatically make it better. You can do this, a quick mental experiment. Imagine a proprietary program, and today they suddenly switched the license and they made it open source. no changes to the program. That did not suddenly make the program more secure. Okay? Perhaps it enabled a process to get it there, but just changing the license all by itself doesn't automatically make it more secure. But that said, they're clear on many cases where FLOSS is better, and there is an underlying FLOSS advantage. Whether or not a particular project takes advantage of those potential advantages is, of course, an issue that acquirers and developers need to consider. If you're acquiring, look, are they taking advantage of this potential and making it a reality? If you're a developer, if you're developing FLOSS, are you ensuring that these things are put in place? I think it's no secret here that FLOSS's use is increasing industry-wide. You should not ignore or make it FLOSS difficult to use. I find in the United States, this is an issue that we're having. Even though FLOSS has been around for a while, there are still, for a variety of reasons, many policies that remarkably make it difficult to use FLOSS, and even in places where it would be obvious that, of course, you should be using or at least considering it, and that's an area I'm still working on. And finally, including FLOSS options when acquiring and then evaluating. I think it's important to note when you're looking at FLOSS, evaluate it. You don't need to, and once you've evaluated, then you can make reasonable decisions. With that, that's the last slide. I have my main talk. I have a number of backup slides, including a little bit about how to develop software and so on, more securely and so on. But with that, I'd like to stop and invite questions if anyone would like to ask any. Thank you very much.